Assalamualaikum and good day. Now we are going to learn Chapter 3, Numerical Methods. Lecture 1 of 2. Let's go and consider a few equations and we'll try to solve them. Okay, the first one is x squared minus 4x minus 5 equals 0. It seems that this equation can be factorized. So we will have x plus 1 times x minus 5 equals 0. So x plus 1 equals 0 or x minus 5 equals 0. Then we'll have x equals minus 1 or x equals minus 5. These two values are exact values. The second equation we are going to consider is x cubed minus 8 equals 0. So x cubed equals 8 and x cubed. X is cube root of 8, that is 2. This is also an exact value. Let's go and consider the third one. Solve this equation. X cubed minus e power x equals 0. We have x cubed equals e power x. The solution for this equation that we cannot find the exact root of the equation above. So in this subtopic, we are going to discuss numerical methods to find the approximate numerical solutions of such equations. Many equations cannot be solved exactly, but various methods of finding approximate numerical solutions exist. The most commonly used methods have two main parts. The first one is finding an initial approximate value, and the second one is improving this value by an iterative process. Initial values. The initial value of the roots of f(x) equals 0 can be located approximately by either a graphical or an algebraic method. Now we go to graphical method. Either A, plot or sketch the graph of f(x). For instance, we have this curve for the f(x). So, the real root is the point where the curve cuts the x-axis. For this example, the root is alpha. Or we can rewrite f(x) equals 0 in the form of f(x) equals gx. Plot or sketch y equals f(x) and y equals gx. In this case, the function f(x) equals 0 is splitted into two kinds of function, that is f(x) and also gx. For example, we have two curves of f(x) and gx. So the real root is at the point where this graph intersects. For this example, the root is alpha. Example 1. Find the root of the equation y equals x cubed by using graphical method. Now, let's go and sketch the graph of y equals x cubed. And we have the y-axis, x-axis, and the curve y equals x cubed. So where is the root? The root for this x cubed is where it is cutting the x-axis. Okay, it is here. Thus the root is 0. Example 2. Find the approximate value of the equation ln x plus x minus 4 equals 0 by using the graphical method. Solution. For ln x plus x minus 4 equals 0, then we have ln x equals 4 minus x. So now, the equation just now is already turned into two kinds of function, and now we can let y equals ln x and y equals 4 minus x. Then we go to sketch these two graphs. So we'll have here the y-axis, the x-axis, and then we mark on the x-axis and also on the y-axis. And this is the curve of ln x. Then this is the graph of 4 minus x. So where is the approximate value of the equation ln x plus x minus 4 equals 0? So it's supposed to be on the intersection of these two curves. Okay, so we'll have here the intersection is at x is approximately equals 2.5. Algebraic method. Algebraic method is another way to find an initial value for an equation that cannot be solved exactly. So we'll have to find two values of a and b such that fa and fb have different signs. So at least one root must lie between a and b if fx is continuous. Let's consider the curve. Okay, so we have the curve like this, and a and b on the x-axis, and then we have fa positive because it is above x-axis, and we have fb is negative because it is below x-axis. So there should be a value where the curve cuts the x-axis to become a root of the function. And another way we can consider this curve. We have a and b, so we have the curve, and then now fb and fa. This fa is negative because it is below x-axis, and fb is positive because it is above x-axis. And there should be a point where this curve cuts the x-axis to become a root of the equation. So we have here x naught as the root for this curve. Example 1. Show that the root of the equation ln x plus x minus 2 equals 0 lies in the interval of 1, 2. Solution. If we have the equation is already equals 0, then we can let fx as ln x plus x minus 2. Then we will input these two values into the function. For f1 equals ln 1 plus 1 minus 2 equals minus 1. This is negative. And then f2 equals ln 2 plus 2 minus 2 equals 0.69, which is positive. Since f1 and f2 have different signs, thus there is a root in the interval of 1, 2. Example 2. Determine whether the root of the equation 2x minus e power minus x lies between x equals 0 and x equals 1. Solution. Let's consider fx as 2x minus e power minus x. f0 is 2 times 0 minus e power 0 is minus 1. This is negative. f1 is equal to 2 times 1 minus e power minus 1 equals 1.6, which is positive. Since f0 and f1 have different signs, thus there is a root between x equals 0 and x equals 1.